I ask you this. Have you ever wondered why you feel a jolt when a car suddenly brakes? Or why a football keeps rolling on the ground until friction slows it down? Today, we're diving into the unseen yet incredibly powerful world of inertia. It's something we experience every single day, but hardly ever stop to think about. Buckle up, because this episode of Scientific Facts may just blow your mind. Let's start with Isaac Newton, the man who first maddened the world with the concept of inertia. He didn't invent it, mind you. He merely observed the laws that govern it. Newton's first law of motion, often dubbed the law of inertia, states, "An object will remain at rest or in uniform motion unless acted upon by an external force." It sounds simple, but take a second to let it sink in. Think of a mug sitting on a table. That mug stays put until you decide to push it. When left alone, it resists any change to its state of rest. That resistance? That's inertia. Now imagine you give it a good shove. The mug starts sliding until the friction between the mug and the table slows it down. So here's the deal. Inertia doesn't explain why things stop moving. It explains why they resist any change in motion or rest in the first place. Intrigued? Good, because we're just warming up. Here's a fun mental exercise. Imagine you're in space, far away from any gravitational pull. You hurl a tennis ball across the emptiness. Without air resistance or gravity to slow it down, guess what happens? It keeps moving forever in the same direction and at the same speed. No stops, no slowing down, just eternal motion. Why? Because there's no external force acting upon it. Welcome to the world of inertia, where objects refuse to change unless forced. But let's bring it down to earth, shall we? You've probably been on public transportation at some point in your life. When the bus comes to a sudden stop, why do you lurch forward? Or when the bus speeds up, why do you feel pushed back into your seat? It's inertia in action. Your body has a natural tendency to maintain its current state of motion, whether that means staying still or moving at a constant speed. So when the bus makes a sudden move, your body resists the change. Understanding this not only helps you appreciate physics, but also gives you a newfound respect for seatbelts. Speaking of moving vehicles, let's talk car accidents for a moment. A grim but poignant example of inertia's importance. When a moving car suddenly halts, everything inside the car, including you, will continue moving at the car's previous speed unless restrained. This is why wearing a seatbelt is essential. It applies an external force that stops you from catapulting forward. Inertia, while seemingly simple, can be a matter of life and death. Think about that. Before Newton entered the scene, humanity didn't have a clear understanding of this principle. Aristotle, a philosopher from ancient Greece, once hypothesized that objects would naturally stop moving unless continuously pushed. Pretty logical, right? Well, Newton shattered this idea with detailed observations and laid the groundwork for modern physics. But let's add another twist to the story. Did you know inertia isn't just limited to physical objects? That's right. It exists conceptually too. Ever had a hard time starting or stopping a daily habit, like exercising or procrastinating? That's the concept of inertia at work within the human psyche. Newton's law mirrors human behavior astonishingly well. Our tendency to stay immobile until something forces us into action, or our reluctance to change direction once we're set on a path, all reflect inertia. Fascinating, don't you think? Now let's get up close and personal with machines. Ever wondered why heavier trucks take longer to stop than lighter cars? It all boils down to mass and inertia. The more massive an object, the greater its inertia and the harder it is to change its motion. Put another way, more mass equals more stubbornness. Engineers and scientists have to factor in inertia when designing brakes, trains, or even airplanes for maximum safety and efficiency. It's an unseen, silent force that dictates how modern machines operate. Can you also believe that inertia even plays a part in our planetary system? Picture the Earth revolving around the Sun at roughly 67,000 miles per hour. What stops our planet from just floating off into the abyss of space? The pull of the sun's gravity and Earth's own inertia. The inertia of the Earth keeps it moving forward, while gravity bends that motion into an elliptical orbit. It's a cosmic ballet choreographed by the interplay of inertia and external forces. But wait, there's a catch. While inertia explains why bodies resist change, it doesn't actually provide the force needed to start or stop motion. That's where external forces like friction or gravity come into play. Think of inertia as the invisible gatekeeper that says, "You shall not move or stop unless acted upon." Let's switch gears to a thought experiment. Imagine wrapping a small rubber ball tightly in cloth and then giving it a spin on a string before letting go. The ball would fly off in a straight line. Why? Because of inertia. Even as you spin it around, the ball wants to keep moving in the straight line direction it had before you intervened. The moment it's freed, inertia takes over, leading the ball to stick to its straight path until gravity or air slows it down. Have you ever observed astronauts conducting experiments on the International Space Station? In a microgravity environment, inertia becomes even more fascinating. For instance, objects tossed by astronauts keep on floating endlessly until someone or something acts on them. That's right. Playing catch with a floating apple becomes a lesson in physics. Now let's take a step back to appreciate how inertia connects us to the cosmos. From cosmic dust particles drifting through the vacuum of space to the immense inertia of a spinning galaxy, this principle shapes the fabric of existence itself. And to think, this unseen force is just as relevant in the galaxies as it is on your dinner table. Mind-boggling, isn't it? And here's an interesting anecdote. Apollo astronauts utilized the principle of inertia during their mission to the moon. By understanding how inertia and gravity interacted, they could calculate their trajectory with amazing accuracy. Without a grasp of inertia, space exploration would likely still be a dream. But before you go thinking it's all highbrow science, remember that inertia also impacts your everyday life. Want proof? Just try pulling a tablecloth from under a fully set table without disturbing the dishes. If done quickly and correctly, the inertia of the plates and cups will keep them in place. It's a classic party trick. Yet behind this simple trick lies a profound principle of science. So there you have it, the might of inertia revealed. It governs the motion of every object and impacts your daily life in profound ways, from the stars in the sky to the smallest habits we form. Inertia isn't just a physics lesson. It's a lesson in appreciating the world's unseen forces. Who knew the force that keeps us moving, or standing still, could be so fascinating? Next time you're in a moving car, cleaning your house, or even looking at the stars, remember this hidden force called inertia. It's not just keeping you in motion, it's shaping the universe itself. Until next time, stay curious, because science is everywhere, and everything